Clustering is a branch of unsupervised machine learning. And the goal of clustering is to identify groups or clusters in your data set. Now, since it's unsupervised machine learning, we're not going to use labels. We're not going to use labels. We don't have labels for our training observations. When people are learning about clustering, they often confuse clustering with classification. But note, for classification, what we're trying to do is we're trying to classify an observation, determine what class does this observation belong in a predefined set of classes. That algorithm was trained with the dataset X with labels indicating what class all those training observations belong into. For clustering, we're not trying to make predictions on observations from a set of classes. Instead, what we're trying to do is identify a similar set of data points and call those similar set of data points as clusters. Set them, define them as a cluster. Afterwards, we can go ahead and take an observation and identify which cluster does it belong to. Sometimes these distinctions will become clear as we go through as examples. Okay, so let's go ahead and talk about an example of clustering. So you might have a data set characterizing your customers. Things like the demographic information and personal preferences, things that characterize each of our customers. One thing you go ahead and do with supervised machine learning is, can we take that data set and predict whether an individual will buy a product? In that situation, it's classification, binary classification. Given the characteristics for this customer, will they buy this product or not? In order to train a machine learning model to do this, we need, of course, the characteristics for a set of customers and labels for those training observations. In other words, whether this individual will buy the product or not. Train a model using X and Y, supervised classification, and then use that model to make a classification. Will this new customer, which I don't know how to label, will they buy the product or not? That's classification. However, what if we don't have labels, or we're not going to use labels for this example here? Let's see what we're going to use the unsupervised machine learning models for. Now let's say we want to apply a clustering analysis. So given our customer information, perhaps we can find several groups or types of customers that exist in our data set. And then once we identify these groups, once we've chosen what's the right number of groups to use and identified and defined those groups or clusters in the data set, then we can analyze those resulting clusters, analyze those resulting groups, and then from there we can derive insight, perhaps start building a profile for each of those clusters. For example, maybe one of those groups or one of those clusters tends to be people in a certain age range who likes the outdoors, things like that. Then we can give that information to a different department, give it to a downstream process. In that process, that department can take those clusters that we identified, recharacterize these clusters, and then maybe they want to take that information and do targeted ads. We have identified in this data set maybe 5 to 6 different clusters, and then from there we can identify what defines each cluster and then develop ads specifically targeted towards those clusters. The idea here is that a targeted ad will do better than some generic ad. Before we know what ads to make, we want to understand our customer base, identify clusters or groups that exist in our data set. Notice in this application, we're not trying to predict something. We're not trying to predict whether they're going to buy the product or not. Okay, so in this notebook, we're going to discuss clustering algorithms as well as the metrics we're going to use to evaluate our clustering algorithms, how well they perform. For this intro, let's go ahead and show you an example of running a clustering algorithm. So we're going to import the makes blobs function. This is a nice way to generate some data. So let's generate some data to identify clusters within it. In this example here, we're going to use the k-means clustering algorithm. We'll define what that means later. This is just for demonstrating purposes. We're going to choose the number of clusters. When we do cluster, we must choose the number of clusters we're going to use before training the model. So in this case, we're going to set 3 clusters. Of course, we'll talk about how we choose the number of clusters. We set 3 clusters. So you have an object representing that algorithm. So let's go ahead and fit it. So we fit on X. Notice we don't pass Y's. Since it's unsupervised machine learning, we're simply going to pass the X. No labels for our observations. And then once we've fitted that model, once we've trained that model, we can also use the predict method for that model. Now this can be a bit confusing because I said before, when we're doing clusterings, we're not trying to make classifications. So yes, these objects have a predict method, but they do something differently than classification. Or we should view them as doing something differently. So yes, it is making a prediction. But what it means in this prediction is that what it's going to do is going to take all our observations in this X data set, in this X matrix, and it's identifying which cluster does it belong into. So what happened here in the previous step in the fit method, with that data set, it identified the location of these clusters. And in the predict method, for all those observations, we're going to say, okay, given where you are in your p-dimensional space, this is the cluster you belong into. This is a cluster you belong into. These clusters we figured out, we identified them previously during the fit and training process. So basically the predict method is going to assign the clusters. Okay, let's go ahead and plot our results. So we're going to plot the data set along with the clusters, along with what cluster these observations belong in. So we're going to run it there. So this is our result there. Notice since we chose 3 clusters, we get 3 different colored blobs. And this is how it's defined what each clusters are.